All right, let's look at an example from an AP exam using the slope field. This is an FRQ from the 2006 AP Calculus AB exam. Consider the differential equation dy dx equals y minus 1 squared cosine pi of x. On the axis provided, sketch a slope field for the given differential equation. Pause this again. I say pause it, do this problem. Try to do the whole problem and then come back and see how you did. And I say pause it and then I ramble for a while. You paused it. So now you just came back because it's all done, or at least what you knew how to do. So let's go through it and check our solutions. I'm just going to go through and, since we're only doing 3, I don't want to write points. I'm going to do a little table. And I'm going to call this -1, 0, 1. This is my x. This is my y. Let's do 1, 0, -1. And so if we plug in y is 1, x is -1. Well, y is 1, this becomes 0. Y is 1, this becomes 0, and this is 0. That's nice. If x is 0, what is cosine of 0? Cosine of 0 is 1. So x of 0, so we plug in 0 for y, we get -1 squared is 1. We plug -1 in for y, we get -2 squared is 4. When x is -1, cosine of negative pi is -1. So we just do negative of that. So we have -1 and -4. Cosine of positive pi is the same thing. So we have -1 and -4. So, okay, y of 1. So we could plot these, sketch these. Slope of 0, slope of 0, slope of 0. -1, or okay, y of 0, we have a slope of -1, positive 1, -1. And at -1, we have -4, positive 4, -4. And from what I understand, what you need to be looking for with these slopes are, is the slope 0? Is it plus or minus 1? Is it greater than plus minus 1, meaning the absolute value is greater than? Is it less than? The absolute value is less than plus minus 1. So those are the dividing lines. You're not going to have to differentiate between 4 and 3, I don't think, because that's going to be really hard to deal with. But there's our slope field. Piece of cake. There is a horizontal line with the equation y equals c that satisfies the differential equation. Find the value of c. So in other words, if we look at this, there should be a spot where we have the equation y equals c. Well, what does that mean? If y equals c, what does that mean? It means the slope is 0, right? The slope is always 0. So if we look at this, now here we can see, oh, slope is 0, slope is 0, slope is 0. We already kind of talked about when y is 1, our slope is always going to be 0. But we want to show that y minus 1 squared cosine pi x equals 0. Well, when is that true? That's true when y minus 1 equals 0 or cosine pi x equals 0. So when y equals 1 or when x equals 1/2, and continues 1/2 plus 2n, where n is an integer. The z means integer. Where n is an element of integers, because then we have 1 over 2, or -1 over 2, or 3 over 2. It's always an odd over 2, so that's going to work. We want y to always be the same. Y is a constant. Well, here, y isn't a constant. X is a constant value, but y can then be anything to go with that. So what we care about is right here where y is a constant value 1. So the answer to this is that c equals 1. And then finally, find the particular solution y equals f of x to the differential equation with the initial condition f of 1 equals 0. Well, first of all, let's play with it a little bit in here. When x is 1, y is 0. So we have this going up here. And if we follow it along, seems, it's coming up towards this. Once it gets here, then it would just be flat forever. It's never going to get to that because here we've got this. These two lines are going to intersect. I'm thinking it's going to do something along the lines of this. And it's going to look like a modified sine wave, roughly. We'll see. We have y minus 1 squared cosine pi x. That's dy dx. So how do we solve this? Well, again, we want to bring the y's to one side, the x's to the other. So this is going to become dy over y minus 1 squared equals cosine pi x dx. dy over y minus 1 squared. Okay, we're going to integrate this. And integrate this. So the negative 2 becomes to the negative 1 over negative 1. So this is negative 1 over y minus 1 equals. The integral of cosine is sine, but it's pi x, so we need 1 over pi sine pi x plus c. Let's go ahead and figure out what c is first. When x is 1, we need a value of 0. So we plug 1 and 0 in, we get negative 1 over negative 1 equals 1 over pi sine pi plus c. Sine pi is 0, so we get c equals 1. And so our solution, kind of ugly right now, is negative 1 over y minus 1 equals sine pi x over pi plus 1. Can we simplify that? Let's make this 1 over y minus 1, negative 1 over y minus 1 equals pi plus sine pi x over pi. Now we'll just take the reciprocal of both sides and get, y minus 1, negative y minus 1 equals pi over pi plus sine pi x. Multiply by the negative, add the 1. Y equals negative pi over pi plus sine pi x plus 1. So let's go plus pi plus sine pi x over pi plus sine pi x. Hey, pi cancel out. And so y equals sine pi x over pi plus sine pi x. Now, do you have to go that far? Probably not. Probably, if this was an AP exam, leaving it here even might have been okay. But wasn't it more fun and fulfilling to get at y equals? Yeah, that's what I'll say. So there you go. Hope you were able to do that all right. And see you in class tomorrow.